Okay, hi. We are going to see the second measure of central tendency, that is median. Median is also known as a positional average. Okay, my focus is off. Why? Because a median does not bother about extreme values. Okay, arithmetic mean is always affected by extreme values. Like for example, if you are having like one, just a simple data. Okay, 20, 15, 30, 12, 22, and then a 90. Okay, right. Okay, so here if you notice, after 1 and 2 the next value is only 12. Okay, then 15, then you have 20, 30, 22, 20, 22, 30, and then there is an extreme value 90. So if you find arithmetic mean for this particular bunch of numbers, it's going to be somewhere, it's going to tend somewhere towards more than 30 or something like that. Okay, if you can check it up, it's a homework for you. Okay, you can go ahead and check, because arithmetic mean is affected by these kind of extreme values. Okay, so here basically it will be affected by this. Okay, so positional average, a median on the other hand, is not going to be affected by any extreme values. It's going to be only affected by the middlemost value. It is not bothered about anybody else but the fellow who's in the very middle of the data. So that is why it's called a positional average. Okay, so here again we are going to divide the data according to the way it is presented. The first being raw data. For a raw data, find median. How do you find median? Median for, I'm not going to divide the paper into 3 parts like last time. I'm going to just straight away okay, let me divide it because that is more better. Okay, we'll see. Right, so for I'm going to take the very same values. Okay, so 20, 15, 30, 12, 22 and 90. Right, so okay, now the first step in median is, as I said, it's a positional average. So position is very important. So we have to arrange the data properly according to ascending order. Okay, now how many values are there? 1, 2, 3, 4, 5, 6, 7 and 8. Oh, okay, here okay, it's an even number. Let me start with an odd number, because that way it'll be easier for you to 1 second, let me put a 25 here. Okay, so I'm going to rewrite it. I'm going to rewrite this data. So I'm going to push a little bit. So 1, 2, 12, 15, 20, 22, 25, 30 and 90. Right, okay, I'll tell you why I didn't take even first, because odd is always easier to understand, then we'll go to even. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we are going to divide this. There's a formula for it. You can go by the formula if you want. There's nothing wrong in that. The formula for odd number is median equal to n plus 1 by tooth value. Okay, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 1 by tooth value. That means 10 by 2. Okay, so 10 by tooth value, which is nothing but fifth value. Which is the fifth value? 1, 2, 3, 4 and 5. This is my fifth value, that is 20 is my median. Okay, so this is a formula method, very straightforward and decent, right? Now there's nothing decent about this, just straightforward, right? So there is no mistakes in this. Very seriously you can get the answer. But now sometimes we are just too lazy to remember such simple formulas. So what we do, we'll see what we can do. There are 9 values, so I'm going to divide the data into 2 equal parts. There are 4 here and 4 here. Okay, so the one left in the middle is this fellow, and therefore this fellow is the median. Finished. Over. Okay, so a median is the middlemost value. It divides the data into 2 equal parts, and for an odd number of value, the median is the middle value, the one which is not divided on any either side. So here this is the median. That is what we have got, so the answer is correct. Okay, now we'll see for even number. I'm going to take the same data, except this time I'm going to remove the 25 that I added and make it into even number, right? Now again we have a formula, median equal to n by 2 plus n by 2 plus 1 items divided by 2. Okay, so 8 by 2 plus 8 by 2 plus 1 item divided by 2, that is 4 plus 4 plus 1 is 5 items divided by 2. So here is fourth is 1, 2, 3, 4. 15 is the answer. Fifth value is 20. So 20 by 2. So here you have 15 plus 20 is 35 by 2. So it's somewhere around 7.5. So this is my median. Okay, so here you have the fourth value and the fifth value, and the average of these two values is the one. So in layman's term, how do we do it? We divide the data into 2 equal parts, 4 and 4, and we take the average of these two middle values. So 15 plus 20 by 2. Finished. 15 plus 20 by 2 and 17.5. So this is for raw data, median for raw data. This is a very straightforward method. Okay, now we will see median for discrete. Okay, now for median for discrete, again there is a formula. Yes, there is a formula, but it's like I don't want to give the formula. Let's just start solving and then we'll find. Okay, median for, we are going to take a very straightforward question. There is no complications here. As you see, x itself, it is discrete, we know it. Okay, this is a very simple and easy question. Now how to find median for this? Okay, solution. Okay, so first thing we do is we write x and f. So 0, 1, 2, 3 and 4, 8, 10, 12, 6 and 4. As I've already said, when you have frequency, total it. Okay, so you have like 8, 18, 28, 30, 36, 40. Okay, so now our steps will change a little bit. Instead of, for the last time we found f into x, here we are going to find cf, which is nothing but cumulative frequency. Okay, so cumulative frequency, so CF. So how to find cumulative frequency? We'll look at only F, don't forget X. Okay, so F, you have the first value 8, cumulative first value is 8. Then 8 plus 10, 8 plus 10 is 18. 18 plus 12 is 30. 30 plus 6, 36. 36 plus 4, 40. Okay, so now if you notice 40 and the summation of this last one, they will be equal. They should be equal, otherwise it's wrong. Okay, you take the first value and put it there. 8 plus 10, 18. 18 plus 12, 30. 30 plus 6, 36. And 36 plus 4, 40. So this is my cumulative frequency. Now I have my cumulative frequency and my summation F. This is a discrete table. So n plus 1 by 2. We're going to find median. Okay, median is middlemost value which divides a data into two equal parts. Okay, so that is why we are dividing it by 2. So here you have 40 plus 1 by 2, which is 41 by 2, which is nothing but 20.5. Okay, so now listen very carefully. You have 20.5. Now look at the CF. A value in CF, 1, 2, 3, 4, 5, you have 5 values. A value in CF which is greater or equal to this 20.5. So which is greater or equal to 20.5? Here you have 30. Here I have 8 which is less, 18 which is less, but 30 is greater than 20.5. Therefore this is marked. Okay, in this X value is 2, so therefore median is 2. We are not bothered about anything else. We are only bothered about X, and the value which is corresponding to this is 2, therefore median is 2. Okay, simple. A very direct question, a very direct answer. We'll check out if you want. We'll do another problem, but you can do it. It's quite easy. So this particular value is the deciding factor. In a CF, the value which is greater or equal to n plus 1 by 2, that is 30. The corresponding X value is my median. Done. So this is for discrete. Okay, now we'll do it for continuous. Find median for, okay, again we are taking a very simple question. But the calculation is complicated. 50, 8, 15, 25, 12 and 10. Okay, here let's see a solution. Class interval and frequency 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 8, 15, 25, 12 and 10. Right. Again we are going to find cumulative frequency. For median, we will always find cumulative frequency. Okay, anything associated with a position, we are going to find cumulative frequency. We are not bothered about any other person. There are the other things that also are positional in nature. That is, for example, quartiles. Okay, I'll write somewhere here for you to remember when we are learning it. Quartiles. Quartiles are things that will divide a data into 4 equal parts. Okay, a data into 4 equal parts. Part 1, 2, 3 and 4. Okay, so these are called a quartile. So these 3 lines are called the quartile. So this is Q1, this is Q2 and this is Q3. So this is a positional calculation also. I can't call it an average, but yeah, it is also another. So this is a positional value and this is a quartile. So quartile also will be using cumulative frequency. Okay, so anything to do with the position we will use CF. Okay, cumulative frequency. So again we are going to find cumulative frequency. The first value is 8. I'm going to just put that. 8 plus 15 is 23. 23 plus 25 is 48. 48 plus 12 is 58. 60 and 60 plus 10 is 70. Okay, and please, again I forgot, you have to find the total. Again this is going to be 70 only because I have already done it. Okay, so now we have CF. Now this is a continuous data. As you can see, there is a class interval. So for continuous data the formula is totally different. Okay, unlike arithmetic mean, here it is going to be a total different formula. The first step is similar, n by 2. Here we had n plus 1 by 2. Here also we had n plus 1 by 2. But here we are going to have just n by 2. So 70 by 2, which is 35. Okay, right. It's very direct thing. Okay, now in cumulative frequency the same rule, value greater or equal to this particular 35. Here this is 8, which is less, 23 is less, but 48 is great. So I'm going to mark this particular group because this fellow is greater than 35. Okay, right. And this class interval is called as a median class. Okay, and we're going to use this fellow completely. We're going to use him to the core. So what do we see here? Okay, let me see. There is a frequency here. There is a frequency value, an F. There is a, this is called a lower limit, L. Here this is my cumulative frequency, CF. The one before that, this fellow, one before, the lesser than this fellow, is called a PCF, previous cumulative frequency. Okay, so now for the formula. L plus n by 2 minus PCF by F into I. Okay, I'll tell you what I is. We saw L, which is the lower limit of this class, 20, plus n by 2 is 35 minus PCF 48, the one before 48 is 23, so 23. Frequency is this fellow, 25, into I. Now I is the difference between 30 and 20. Okay, 30 and 20, that is 30 minus 20 is 10, and that is my I. Okay, so now for the calculation, I'm going to write it here itself. It's okay, no place actually, but we'll try. Okay, So 35 minus 23 is 12 by 25 into 10. Okay, this is equal to 20 plus, shallow calculator. 1 second. 12 by 25. Okay, this is 12. Now this become 2.10. Okay, 2.10 0 60. Okay, something like 20 point something it will come. My daughter has got her mobile. Okay, we'll check it out. We'll do the calculation that. Calculator. Seeker. Thank you so much for the calculator. Okay, let's see. 12. Okay, divided by 25. Okay, equal to 0.48 into 10. Okay, equal to 4.8 plus the last one is 20. So 4.8 and this will be 24.8. Okay, so here you have 24.8. The therefore median is 24.8. If you notice, the median class is 20 to 30 and the median is 24.8. So it will be somewhere in between 20 and 30 only. So this is my median. So please remember very carefully, this is how you find median for a continuous data. So for a discrete, you have these two formulas. For a raw data, you have these two formulas. For a discrete, you have this formula. And for continuous alone, you have this big fellow. And this is very, very important question.